So I'll just hand over to Imole from here to take over the Python class and functions.
All right, thank you, Miss. I'll just share my screen.
Thank you.
All right, great. Okay, so thanks. Yeah, I'll try my best to see how far we can go, like within 15 minutes, try to touch on the important things. And yeah, it's like lovely insight so far given from what you've said. And basically it's all of those things that we then start to build on. So what I want to discuss here is basically object-oriented programming, where I'll touch mainly on functions, class, and objects. So in essence, one of the things that Python is all about is bringing up the idea about object-oriented programming, which is also referred to as OOP. And the main goal here, like I've highlighted, is to create usable and maintainable code. Because when, like you've seen, you start to write some codes in different cells, and you find out that there are things that you have to do all over again in that sense, meaning they are pretty much workflows that you have to repeat. So in this case, you have to think of ideas about automating them. And I've said here that in OOP, in Python, OOP is supported through the use of classes and objects. And in Python, almost everything is an object, has a type, value, and identity. So for me to break this down, I, in the meantime, was trying to come up with something that would be more explanatory. So we can have a look at this, for example. So yeah, I drew the shape of a box. We could, like I was looking at when Promise was walking you through integer types and she defined some integers, data type rather. So she defined integer and different types. So if you, let me put it this way. So let's remember what I've said. In OOP, you said it's supported through the use of classes and objects. Classes and objects, that's one thing to take forward. So then the question then comes to mind is, what's an object? An object itself it's a custom data structure containing data and code. So it's a data structure like you've been seeing, you've walked through data structure with Promise. And in this case, we're talking about something custom, which you can customize yourself pretty much to the taste of what you want. And the object, you start to think about it having data, in other words, attributes and codes, which in this case is functions that refer to method, which I'll still break down. So in basic sense, it's more of like a unique instance of some concrete thing. Like in this case, let's imagine this is the object itself, which is defined to have a type int, which is what I was referring to here. The object has a type, a value, and identity. So the type int, the value 9, and then the identity is where it is stored somewhere within the memory of your of the PC itself. It's stored. So now, in other words, to make this make sense, let's think of it like a noun and a verb. Like a noun, you could say it's something, right? In this case, that something, that thing is the object, and which can have, let's say now we are talking about, let's say, describing someone, for example, or you can just start to think about attribute. Let's say a man, we're looking at a boy named, or let me just use a funny name, Andre. That's the name of the boy. So you can start to think about the boy having properties like, okay, his height, his body shape, facial structure, and all. And then the verb, which is like the actions which that thing can do, or that person can do. The person can talk, can walk. In this case, I use like integer. I can do like addition, multiplication, and that's where we refer to as the code, the functions itself. So this is like the basic thing to know for now. I'll come back to this and just break down the many things about class and the other ones. So coming back to that, so if we then think about it, like I said here, it's the object itself has a function embedded in it. So we start to break down what the function is a little bit more. So a function itself are ways to just group set of instructions together and give them a name, which allows you basically just doing something much repeatable and making managing the complex tasks. It's like the definition I've put here. So on that basis, I would just make some example of what a function is. So you can just think about it like in terms of function, I'm just creating actions, like the method, which is what I talk about, like that's like the verb part of it, which in a way we can start to, when we go down the line, integrate it as a larger part of something. So let's just see what it's like. Okay, so well, I don't know if we have time enough. So if we want to define a function in Python, we'll start with the keyword using def. Let's say I want to do like give it a name. In that case, the action which is doing my function. If you see the function, and you close the parentheses, and then you have a colon next to it. And let's say this function, we just want it to do something simple. Say print, yeah, print a. So I define the function. So for me to call this function, which is like the action I want to do, I just say my function and close the parentheses and it says a. So it's doing an action there. And now we start to build on this in the sense that we can start to think about enriching the action. So if we want to enrich the action, that's where we can start to add some arguments into this parenthesis. Yeah. And so let's see in another sense, if I say I want to do perform an action whereby I can simply add two numbers, X and Y. In any case, we could say, okay, what is the number? X, maybe the person say X is 5, and then the person says Y is 6, Y is 7. So I can do X plus Y and I get my answer. But let's think about it. Each time the person is coming with a new number, I say, okay, I want to do another addition. I want to do that. Now you see how it can be more repetitive, like entering into different cells and writing X, Y again all over. So that's where a function becomes useful. Like you just pass an instruction and it does that each time as you supply an argument into it. So in this case, I could say, okay, I want to do adding of number, def add number. So it's going to take the arguments X and Y, which you can still define as anything. And you can, like, I mean, in terms of making it more readable, I could say number 1 and number 2. And then I have the colon next to it. And thereafter, it's going to be number 1 plus number 2. In this case, using the return statement. So you have, so in this case, I want it to return, meaning it performs this action and returns that value for me. In this case, I didn't have a return because the print itself is already an inbuilt function in Python, which is automated in that process, like it returns a value. So if I then do this art, so let's say the person comes next time and say, okay, I want to add 2 new numbers. I can do add number 6 and 9, and then it's added to give me 15. So you can think about it in the sense that this way it's more easy to maintain your scripts. You don't have so many cells and you can reuse it. So that's the idea about it. And also simply readable. So the other part to it is, like I said, there are positioner and keyword arguments. Positioner in the sense that it takes position. The position, it's also sensitive as to how you pass this arguments into your function. So if I would make an example of this, say, let's do an example using division. So I want to divide 2 numbers, define the numerator and then the denominator. Okay, so in this case, return division, which is numerator divided by the denominator, right? So this is the function which I've just built, or in other words, in the more simple sense, an action which I want to do. And then I say, okay, divide. Then the person supplies me, oh, the numerator is 100 and the denominator is 5. So that gives me 20.0, which is a float here. So now we see how this works, but where the term I'm trying to say positioner is in the sense that if I bring in the 5 first before the 100, so you see it's different in that case because you have to bring in the numerator first, just as I've defined it within the parentheses of the function. Another way is I could actually overwrite the position if I specify the parameters itself and say, okay, if I say denominator is equals to 5 and the numerator is equals to 100. So that way I can not care really much about the arrangement as long as I pass the correct naming of what I've placed into the parentheses. So nesting function, yeah. So nesting function is just the idea whereby I can start to have a function inside a function.
Sorry, please can you zoom in your screen? I think somebody wants feels like it's small. So just zoom in.
Okay. Is it better now?
Yeah, you could still zoom in a bit more.
A bit like this? Better?
Okay, I think it's fine. Yeah, thank you.
All right. So nesting the function, yeah. So the whole idea is, of course, sometimes we can write a script whereby you are defining an action, right? But then you just feel like it's becoming too much. And in that point, when you start to write a very long script and you start to think about if it's really maintainable. For you, it's understandable, but what if you pass it to the next person who is going to use it? So sometimes it's good to write scripts in a way whereby you can actually have them readable and maintainable such that it can be easily debugged. And of course, sometimes it's better to break down the action. It's like saying if I have to do a certain thing. It's just like the process of how you get yourself set up for this tutorial, right? For this webinar. You have to first download Anaconda, like install Python. So those are like different actions. So we can all doing a certain thing, but embedded within each other. So if I quickly just say, let's say we want to make something more complicated, like computations for min max. I can define this and give it a name computation for min max values. And this min max value, well, can take several numbers. Number one, I think, let me just do this here. Okay, let me not confuse. So let's just say it takes 5 numbers to make things easier. Num 3, num 4, num 5, and then put a colon. So the first thing I want to do is I want to write a function that gets the min and max values of those numbers. So I can say get min max, and then let's say max value. So let me just do something interesting, which I wanted to touch on here, which is like the keyword argument. So we can actually collect a tuple of like saying arguments, we can define to any extent. Instead of writing these numbers, I'd rather just do this and say args, which is what I wanted to explain here. Keyword arguments, in this case, taking non-keyword arguments that are then converted into a tuple inside your function. So in this case, I can just say min of the args, and then the max of the args also. And then I'm going to return the min value and the max value. But then there's something else I want to do with this min and max value. Let's say I want to add them together and I want to multiply them together. So I can define another function inside the main function, which I'm building, called computation for min and max values. And then say add values. In this case, I just say return. Now I call this function, which is earlier defined, So I'm starting to nest function into one another and say get min, max. And because this return is returning two elements, I'm going to call the first one by the index, which promise has walked us through, and then get min max by the second index. So this takes position 0 and this takes position 1. And then thereafter, the other part of it quickly define def multiply values. So I'll just copy this and then multiply the values. So what am I going to do? Then set this different functions to a variable add and then add values, calling this to do the action, and then multiply values. Hope it's not getting too complex. And then return add and multiply. So what am I doing? I just want to do some messy thing with the min and max value of some numbers that anyone will give me. The first thing I want to do is get the min and max value of those numbers, but then I want to perform an action whereby I can add the value, multiply those value. So this is where I start to make extra functions for that, add values and multiply values. And then I can then call these functions inside the function and say add values, multiply values, return. So if then we have a situation whereby someone says, okay, someone gives me some numbers, computation for min, max values, and the person gives me numbers like, let's say 55, 60.4, 90, 100. Oops, okay, yeah.
There's an error on, yep, there.
Yeah, thanks for that. I didn't close that. Yeah, cool. Thanks. Yeah, so yeah, because I didn't call the function exactly as it is, closing the parentheses. So by doing that, computation for min max values. So it gets the min and max value. In this case, the min value is 55, the max is 100. If you add them up, you get 155. If you multiply them, 5,500. So this is it. So hopefully this will start to give you ideas on making some things much easier. And instead of writing multiple cells, you can start to like think about probably nesting functions or using functions to make things easier and maintainable and reusable.